Hey y'all, this is Mrs. Blasky. We're moving on to lecture video for topic 7.2. This one we're going to talk about pH and pOH. pH and pOH are the mathematical or numerical representations that we use to determine whether something is acidic or basic, and how acidic and how basic they are. So all of the math about pH and pOH are based on something called autoionization of water. So when water exists just hanging out by itself, a very, very, very small percentage of those water molecules go through that acid-base reaction that we were talking about in unit 7.1. So water can act either as an acid or a base. So one of these water molecules is going to act as an acid and donate away a proton, turning into hydroxide. The other water molecule is going to act as a base, accepting that proton and turning into the hydronium ion concentration. So at 25 degrees Celsius, which is about room temperature, if we take the concentration of hydronium ion and hydroxide ion in a sample of water, we get a value of 1 times 10 to the negative 14th. This is a constant value at 25 degrees Celsius, and pretty much we're only ever really going to talk about it at 25 degrees Celsius. And so we call this Kw, or the water equilibrium constant. Sometimes you'll see it called the autoionization constant for water. All of those things mean the same thing. And so what that tells us is it tells us that we have a constant value for the product, the multiplying product of the H plus concentration and the OH minus concentration in any solution. So however much acid we have going on, multiplied by however much base we have going on, is always going to equal that 1 times 10 to the negative 14th. So knowing that allows us to calculate the hydroxide ion concentration or the H plus concentration for any substance. If they are equal to each other, we know that that substance is neutral. So in pure water, each of those is equal to 1 times 10 to the negative 7. That multiplies out to give us that 1 times 10 to the negative 14. If my hydroxide ion concentration is larger, then that solution is basic. If the hydroxide ion concentration is smaller than the H plus concentration, then that solution is acidic. Now, those numbers also help us figure out the pH scale. So P, anything that's a P function, P means negative log. So my pH is taking the negative log of my H plus concentration. There's also a pOH, which is the negative log of my OH minus concentration. Those two values added together should always equal 14. That 14 comes from that 1 times 10 to the negative 14 value that's going on there. So if my pH is between 0, sometimes it can actually be negative, it can be slightly less than 0, and 6.99, the solution is acidic. If the pH is exactly 7, then so the solution is neutral. It is neither acidic nor basic. And if the pH is above 7, then we say that solution is basic. So as long as we know one number, we can always determine the other numbers. There is also a way on your calculator to do what is called an anti-log. So P functions and log functions like this, if you haven't done them in math yet, for our purposes, it's pretty much just a button on your calculator. But so if I have the equation pH equals negative log of H plus, and let's say I know the pH. Let's say I know the pH is 3, and I want to know the H plus concentration. So if I go 3 equals negative log of H plus, I can't just divide both sides by negative log to find the H plus, right? I can't do that. It's more like a square root where I have to undo the square root function by squaring something or like that. So we talk about anti-logs, which on your calculator, if you look at your log button, The anti-log is whatever shift function or second function is above your log button. So for log logs, it's 10 to the x. So these are all on your equation sheet. The anti-log equations are not on your equation sheet. So 10 to the negative pH equals your H plus concentration, or 10 to the negative pOH. Whoops. Equals your OH minus concentration. So these two equations are not on your equation sheet, but they should be. So let's try out number 9 first. I want you to give this a try first, and then I'm going to show you some tricks for ways to be able to do this without your calculator. All right. So for A, if my OH minus concentration is 1 times 10 to the negative 5, I know that my H plus concentration times my OH minus concentration have to equal 1 times 10 to the negative 14th. Now, sneaky thing about scientific notation. When I multiply scientific notation, the exponents add together. So if I need 1 times 10 to the negative 5th times something to equal 1 times 10 to the negative 14th, I can just figure out what exponent needs to work so that negative 5 plus something equals negative 14. Especially since this has a 1 in the front, that's not going to mess with my numbers at all. So if my OH concentration is 1 times 10 to the negative 5th, that means that my H plus concentration should be 1 times 10 to the negative 9th. So in this case, it says state whether the solution is neutral, acidic, or basic. My OH concentration is larger than my H plus concentration, so this is going to be a basic solution. For B, 1 times 10 to the negative 7th. Again, something times 1 times 10 negative 7th needs to equal 1 times 10 negative 14th. So in this case, my H plus is going to have to be 1 times 10 to the negative 7th, because negative 7 plus negative 7 gives me negative 14. Since they are the same, this solution is going to be neutral. Now in C, I've got a much larger number here. I've got 10 molar H plus, which we can just think about. 10 is the same thing as 1 times 10 to the positive first, right? So if I still need that times something to equal 1 times 10 to the negative 14th, I need my OH concentration to be 1 times 10 to the negative 15th, because positive 1 plus negative 15 gives me that negative 14. In this case, my H plus concentration is way bigger than my OH minus concentration, so this solution would be acidic. Solving for a pH or getting an H plus or OH minus concentration from a pH is a very common sort of first step to a lot of our acid-base questions, a lot of the problems that we're going to be doing, and doing some of that math without a calculator is going to be very common on the multiple choice. So this is something that we're going to work on, and we'll make sure that we focus on mental math and what's going on in here. So again, make sure that you try out these other example questions. There are some asking you to go from concentration of ions to other concentrations. There's some that are asking you to find the pH from concentration. Here's one that's asking you to find the H plus and OH minus concentrations from the pH. So it's all about manipulating those equations to figure out what's going on. So with all of that, make sure that you're practicing these. Make sure we can do some estimates about what's going on. And we will make sure to see how this pH calculations incorporate into everything else we're going to talk about. I will see y'all later. Bye.